So dear students, welcome to my YouTube channel PCM Academy, and we are in a lecture series on JEE Main, NEET and JEE Advanced. In the last class I have discussed about some problems on mass-pulley system, and basically we have learned some concepts how to solve mass-pulley problems. Now in this class we will solve some more problems based on the concept of mass-pulley problem. Okay, so now let me see what is the first question. So this is the first question, and the question is, find the tension in the string and acceleration of each block. You have to consider this figure. Two pulleys and two masses are attached like this. And one thing you have to consider here that I have not written, that all the surfaces are frictionless and the pulleys and the strings are massless. Okay, so this is the obvious assumptions, when we are talking about Newton's laws. So here we have already I have said that the friction is neglected here, and I have told you when I was talking about the tensional force and something like that, where we have to consider the string is massless, inextensible also. So we have earlier discussed about these things. So now let me solve the questions with these kinds of assumptions. What is the tension in the string, and what is the acceleration? What are the acceleration of blocks? So to find out this thing, let me first see what are the forces acting on the blocks. Here the two objects are here. One is 1 kg blocks, and another is 2 kg block, and another is 1 kg block. So the forces acting on 1 kg blocks are in downward direction. The force is 1g, that is mg. So m is 1 here. So you can write it as mg, and the tensional force, let me take it as T. So if this force is tensional force is T, then the tensional force, as this is the same string, you can see here this string and this string and this string are same. So one string is actually connected totally for these two pulleys. So if this is 10 T, so this will also be T, and this will also be T. Now you can see if this is T, this is also T, then this will obviously be 2T. Okay, so the force acting on this block is 2T, and the force acting on this block is A. Now if we take the acceleration of 2 kg block is A, then the acceleration of 1 kg block will be 2A. It will be 2A. And why this is so, we have discussed in the last problem in the previous video, that tensional force is always inversely proportional to acceleration for this kind of mass pulley constraints. This is only applicable for mass pulley constraints. Mass pulley constraints. I have proved this thing with an example. Mass pulley constraints, and this is just signifies that here the tensional force is twice than the tensional force here. So the acceleration will be twice here. Okay, here the tensional force is twice, and the tensional force is inversely proportional to acceleration. So if we take acceleration here as A, so here will be 2A. Okay, or if we take acceleration here is A, then here will be A by 2. So always where the tensional force is more, their acceleration is less with respect to other. So when we compare between acceleration between this 2 kg block and 1 kg block, actually we want to find out the relation between the acceleration of 2 kg block and 1 kg block. Then we have to always consider the tensional force acting on that blocks only. So we have to compare the tensional force which are acting on that blocks. Here the tensional force T is acting on 1 kg block, and here the tensional force acting on 2 kg block. And on 2 kg block the tensional force is 2T, and on 1 kg block the tensional force is T. So if on 2 kg block the acceleration is A, then on 1 kg block the acceleration will be 2A. So now what we have to do, we have to make free body diagram of 2 kg block as well as 1 kg block. So let me first draw the free body diagram of 2 kg block. So what is the FBD of 2 kg block. So now if we draw the FBD of 2 kg block here, so what are the forces acting on this block? One force is obviously 2T. Okay, 2T along this direction. This is obviously 2T along this direction. Okay, 2T. And two other forces are also here. One is the weight, that is 2G, and another is the normal direction N. But these forces are not participating for the motion of this object. You can write here, you can draw the forces N and 2G here, and the acceleration is along this direction, and the acceleration we have taken A. Okay, now if we talk about the FBD of second block, that is obviously for the 1 kg block. Okay, so now let me draw the FBD of 1 kg block. Okay, so FBD of 1 kg block. So here is 1 kg block, 1 kg block, and two forces are acting. 1G in downward direction, and tensional force, that is T, in upward direction, and acceleration 2A in downward direction. Okay, so now what we have to do, we have to just write down the force equation, that is the equation of motion. But before writing down the equation of motion, we have to consider the coordinate system, appropriate coordinate system. So here we can see the motion of this block of 2 kg along x direction, and this is along y direction, and this is vertically. So we always like to choose the vertical direction as y axis. So if we choose here the axis, okay, so let me choose that this is x axis and this is y axis. But as the motion is along the downward direction, so I like to choose the positive x axis along downward direction. So let me take this as negative direction. Okay, so I have taken positive direction as the downward direction here. So now let me writing down the equation of motion. So here if we write down the equation of motion, here will be the summation effects. Okay, you know the equation of motion I have discussed earlier, that is m into ax. Now what is the summation effects here? Here the summation effects is nothing but 2t. Okay, this is 2t, so summation effects is 2t. And what is the mass is 2 kg, and acceleration is a, so 2a. So t will be nothing but a. So let me take this as equation 1. Now if we write the equation for this object 1 kg block, so it will also be summation if y is equal to m a y, because here the acceleration or the motion is along the y direction, and the summation if y is nothing but 1g minus t. So here is 1g, so you can write in 1g, this is along the positive direction, and tensional force along the negative direction, so it will be 1g minus t is equal to 1 into, here acceleration is, mass is 1 kg and acceleration is 2a. So here the equation will be g minus t is equal to twice a. Now if we put t as a, so it will be g minus a is equal to 2a. So 3a is equal to g, and we can take g as 10. Okay, so a will be 10 divided by 3 meter per second square. So this will be the acceleration. Now what will be the tensional force? So you can just substitute here, because t is a for this object for 1 kg block. Okay, so for 1 kg block, the tension on 1 kg block if we want to write the tension on 1 kg block, so we can write over here that tensional force on 1 kg block, you can see here, is equal to T, so will be obviously 10 by 3 Newton. And if we talk about the tensional force on 2 kg block, then it will be 2T, so it will be 20 upon 3 Newton. Okay, and acceleration of 1 kg block is 2a, so it will be 2 into 10 by 3, that is 20 by 3 meter per second square. But if we talk about the acceleration of this 2 kg block, so this will only be 10 by 3 meter per second square. So this is how we can solve this kind of problems. Okay, so now let me move to the next question. Similar kind of questions, I'll have to solve more questions. So this is our next question. Okay, and what is the question here? Calculate the acceleration of either block and tension in the string. Same question. Okay, so here you can see one string is involved, and if we take this as T, so this will also be T, and this will also be T. So if we talk about the tensional force on M, then the direction will be in this direction, because you know the tensional force act always away from the object. So if you talk about the tensional force on M, then it will be away from M, and if you talk about the tensional force on this pulley, then it will be away from this pulley, so it will be in opposite direction. But what we have to find out here, or we want to know here, is the tensional force on capital M. So the tensional force on capital M here is T, and the tensional force on this capital M, on the for this mass, there is also tensional force T. So you can see the tensional force are same, so the acceleration will must be same. So if we take the acceleration of capital M in this direction is A, so obviously for this mass also the acceleration will be in this direction A. So now let me again draw the FBD of two masses. For the horizontal mass, the mass which is on the horizontal table, that is capital M. So let me take first this mass. Okay, so for this mass, what will be the free body diagram? This is capital M, and the force which is acting on it along this direction, this is T, and the acceleration is also along this direction, that is A. Okay, so as the motion is along the horizontal direction, so we don't need the forces along vertical direction. So if we take this direction as the positive direction, so for this object, if we take it, use the equation summation fx is equal to max, then here summation fx is only T, and the mass is capital M, and the acceleration is A. So this is our equation 1. Now if we talk about for this mass, which is same mass, I think is capital M. So here is mg force, and along the vertical direction the force is capital T, upward direction, and the acceleration along this. So if we take this direction as the positive direction, then the equation of motion will be summation fy is equal to may, and we can write over here the equation. We can write over here that summation fy is nothing but mg minus T. So you can write over here that mg minus T is equal to m into A. Okay, now if we put the value of T from this equation here, we will get acceleration. So mg minus ma is equal to ma, so mg is equal to twice ma. Okay, so just a is equal to g by 2. Okay, so here a will be just g by 2. So this is our acceleration A. So and both the block has the same acceleration, so acceleration will be g by 2, and tensional force will also be same, so we can put here, so tensional force will be mg over 2. Okay, so this is how we can solve the questions. So now let me move to the next question. So this is our next question. Here what we have to find, we have to find the mass capital M, so that it remains rest for the figure. Okay, So how it can be at rest? Okay, if the net force on this block will be 0, capital M, so it will be at rest. So now let me first see what are the forces acting on these blocks. So here if we take the tensional force T, then the tensional force here also will be T, and this T and T will be shifted here, that will be 2T resultant force actually, and if this is 2T then this will also be 2T. Okay, now let me draw the free body diagram of all the three objects. Okay, so what will be the free body diagram for capital M? So for capital M, you know, along this for this block first. Okay, so along this direction it will be mg, and vertically upward direction this is twice T. And for 3 kg block, for this 3 kg block, what will be the forces for this 3 kg block along this direction? So so that it remains rest. Okay, so if it is remain rest, then all the masses have zero acceleration, so there will be no problems. So the problem is easy. Okay, so T. In another problem we will see that when this system is moving, then the problem will be more complicated. Okay, we have already discussed about the acceleration relation between the blocks for this kind of system, and we will discuss later on the total equation of motion and what is the tensional force, what are the acceleration. We will see this kind of problems later on, but here the problem is so easy, as he has said that the system is at rest. Okay, so this is the word that makes the problem so simple, because there is no acceleration. Okay, so it is obviously very easy in that sense. So for 2 kg, obviously along this direction 2z, and around this direction it is also T. Okay, so you can see from this figure. Okay, so there is a problem. We cannot say that the whole system is at rest. Okay, so the question is find the mass m so that it remains constant. Okay, so the language is find the mass m so that it remains constant. That means only the mass capital M remains constant. So if the mass capital M remains constant, it means that this pulley is at rest, but they can slide. This 3 kg and 2 kg block can slide. Suppose this 3 kg block is sliding upward, sorry, it will obviously will be in downward direction because the mass is heavier, so 2 kg block will be in upward direction. So let me take this acceleration as A. So between these two blocks, 3 kg and 2 kg blocks, they can move, they can slide through the pulley, but this pulley itself, the second pulley, is itself at rest. This is the condition. If the capital mass M is at rest, then the second pulley should be at rest. Okay, so if this pulley is at rest, then the acceleration of 3 kg and 2 kg block will no longer depend on another effects. But if this pulley is moving, then we have to use some relative acceleration. So we are not discussing this thing. I have told earlier, we will discuss these kinds of problems later on. Okay, but here this 3 kg and 2 kg block are not at rest. It should not be at rest. It cannot be at rest because the masses are different. You know, here from this equation, if they are in rest, then T is equal to 3g and here T is equal to 2g. So it can't be happened. In the same tensional force, in the same system, the same tensional force should not be different. So these two blocks have to move. Okay, and along which direction it will move? It will move along that direction in which directions the heavier masses is hanging, and here the heaviest mass is 3 kg. So 3 kg block will move along downward direction, so 2 kg block will move along upward direction. So the acceleration will be for 3 kg block in this direction, So what we have to find out, we have to find out tensional force first. If we want to find out the mass capital M, so we have from this figure diagram that 2T is equal to mg, just mg. So what will be M? M is nothing but 2T over G. So we have to find out T. So what will be T here? So for this mass, you can write down the equation that 3G minus T is equal to 3A. So T, what is T? Or A you can say. So if we talk about A, so A will be here 3G minus T by 3. And from here we can write at T minus 2G is equal to 2A. So A will be T minus 2G by 2. Now if we equate this to equation of 1 and 2, so let me take this as equation 1, this is 2, okay, and this is 3, and this is equation 1. Now from these two equations we can find the tensional force, and then we can substitute T in this equation 1. So let me find out first. Let me first find out. Okay. So from equation 1 and 2, and 3. So from 2 and 3, we can write as 3G minus T upon 3 is equal to T minus 2G upon 2. So it will be 3T minus 6G cross multiply. Okay. So it will be 6G minus 2T. So it will be 5T is equal to 12G. Okay, so 5T is equal to 12G. So if we put T, so T will be 12G by 5. So T will be 12G by 5. So now let me put T here in this equation. Okay. So what will be T? So 2 by G into 12G by 5. So G will be cancelled out. So it will be 24 upon 5, which will finally be 4.8 kg. Okay, so this is the mass M. So this will be the value of mass M, such that this mass will be at rest. Okay, though the 3 kg and 2 kg block are moving. So now let me move to the next question. So this is the next question, and probably the last question for this class. Okay, so what we have to find out here, mass M1 and M2 are given. One is 300 gram and another is 200 gram, and force is what? 0.4 Newton. So find the tension T and the acceleration of M2. Okay, so what will be the tension? So the tension on the pulley will be T along this direction, you can see, and along this direction it will also be T. Okay, same on the pulley. So the tensional force on this object, on this string, will be 2T. So here we have written here T, so let me put a T prime. Okay, and this T prime will obviously equal to 2T. So now we have to find out T prime, so we have to make the equation of motion first. So let me take the acceleration of this block m2 is a. So we have to find out the acceleration also, because we don't know the acceleration here. Another force F is acting over here. Okay, so let me take the acceleration along this direction is a. Now what will be the free body diagram of m2? The free body diagram of m2, you can see one force is along this direction, and tensional force obviously will be along this direction 2t, and acceleration is along this direction. So equation of motion will be F minus 2t is equal to m2a. Okay, this will be the acceleration. Now here some relations are given here, that m1 and m2 are given. Okay, m1 m2 are given, F is also given. Okay, so here given is m2 is given and F is given, but we have to find out t and a, so two variables. Yeah, so we need one more equation. So let me draw the equation of motion for this mass m1. Okay, so what will be the acceleration of this mass m1? So m1 will move along this direction. So when this m2 will be moving along this direction, this forward direction, so the m1 will be in this direction, because if we further move it, so the string will be moving along this direction, forward direction. Okay, so the mass m1 will be moving along this direction. So what will be the acceleration? So the tension is T here. Okay, tension is T to this rope, but here the tension is 2T. So when the tension is 2T, we have assumed that the acceleration is A. So when the tension is T, we have to take the acceleration as 2A. Okay, so the acceleration will be here as 2A. So for the mass m1, if we draw the free body diagram, okay, so along this direction it will experience a force T, but its acceleration will be twice, because here the force is, you can see 2T, but we have taken the acceleration is A. So if here the force is 2T and the acceleration is A, then here if the tensional force is T, then the acceleration should be 2A. Again, from the relation, T is inversely proportional to A for the mass-pulley problem I have shown you earlier. Okay, so you can see that for the simple problems, when we are talking about some simple problems, only two or one pulley are involved. In that case, just if you use this relation, you will get that you don't need to actually a constraints equation in detail. Okay, so this is very helpful trick for you to solve this kind of problems. And if you talk about JEE main and neet, so they are not asked some more complicated problems rather than this. But in JEE advanced, we need this kind of thing sometimes, and I will discuss it later. Okay, so let me first solve these questions at least in this level. And you can see all the four problems that I have shown. In each and every case almost this relation is used. The T is inversely proportional to 1 by A. Where the tensional force is more, the acceleration is less, and where the tensional force is less, the acceleration is more. And sometimes it's double. Most of the cases it's double, because the tensional force, the relation between the tensional force is T and 2T. So the relation between acceleration should have A and 2A. And where 2A, where the tension is T, there the acceleration is 2A, and where the tension is 2T, there the acceleration is A. Okay, so this is the trick to solve this kind of problems easily. So this is the equation. So the equation diagram, so the equation will be T is equal to just m1 into 2A. Okay, m1 into 2A. So now if we put this value in this equation, So what we will get? We will finally get F minus 2 into T. So 2 into T is 2m1a, 2m1a, and that is equal to m2a. So what we have to find out first? Acceleration A of mass m2. So this is m2a. So let me further solve it. So F minus 4m1a is equal to m2a. So F is 0.4 Newton. So you can put here. So let me take further. So it will be F is equal to, so F is equal to 4m1a plus m2a. So if we take common here a, then it will be 4m1 plus m2. So a will be F divided by 4m1 plus m2. Okay, so F here is 0.4 Newton. M1 is, you can take it as kilogram, so it will be 0.3 kg and it will be 0.2 kg. So 4 into M1 is 0.3 plus M2 is 0.2. So it will be 0.4 divided by 1.2 plus 0.2, that is 1.4. So it will be 2 by 7 meter per second square. So acceleration is 2 by 7 meter per second square. So we will get then the tensional force also. Okay, so T will be just, we substitute M1 as 0.2, okay, into 2 by 7. So 2 into 4, 4 into 2, that is 0.8 divided by 7. Okay, and if we talk about the tensional force on M2, then we have to multiply this with 2. So 2T will be this. Okay, so this will be 1.6 upon 7. So you can solve these problems like this. Okay, and all the problems I have taken from the book DC Pandey. Okay, so I have said earlier that I will follow actually these two books, okay, DC Pandey and AC Verma, and I will solve separately the AC Verma book later on, okay, chapter wise. But now the problems I have taken from sometimes DC Pandey, from sometimes AC Verma, okay, or sometimes another books also. So here my purpose is that I have discussed all the theory first and then some solved example on them. Now, when you are understanding the problems, how to solve problems, the details much about theory, then I will solve the total exercise of H.C. Verma, and if time allows, okay, I will also solve for J Advanced, basically IE. Okay, so now first target should be the DC Pandey and AC Verma, and then you can move to IE also. Okay, so thank you.